Hey everyone, my name is Miriam and I'm a co-op student here at Pinax. For this term, I've been working on an exciting project that involves bulk loading data into ClickHouse using the Substream Sync SQL tool and the Antelope Token API. But before we dive into the details, let me introduce you to my teammate who will be joining me in this video.
Hi everyone, I'm Yad. I'm also a co-op student here at Pinax. I've been focusing on the DevOps aspect of our project, ensuring that our ClickHouse deployment runs smoothly and efficiently in a Kubernetes environment. I'll pass it back to Miriam.
Thanks, Yad. So first, what exactly is a substream? Substreams are a specialized indexing technology for blockchain data. They allow users to categorize and segment blockchain information, enabling a more focused and efficient way to handle data. With substreams, you can extract specific data types from blockchains, apply custom transformations to refine the data, and send it to various destinations like databases or files. These destinations are called sinks. Essentially, substreams serve as a powerful tool to manage, analyze, and utilize blockchain data effectively. Now that we've covered substreams, let's move on to ClickHouse. ClickHouse is an open-source columnar database management system designed for real-time analytics. It's known for its high-speed query performance, scalability, and robust support for handling vast amounts of data. ClickHouse's architecture is optimized for analytical queries, making it an ideal choice for our project. Its columnar storage format and multidimensional data model allow for efficient compression and query execution. This design aligns perfectly with our goal of processing and analyzing blockchain data effectively. Let's talk about how we sync these substreams with ClickHouse using the Substream Sync SQL tool. This tool streamlines the process of syncing substreams modules directly into ClickHouse. The Substream Sync SQL tool simplifies the integration process. It requires specifying the database connection details in the manifest and sets up the necessary tables within ClickHouse, reducing manual configuration and setup time. This automation allows us to focus more on data analysis and less on infrastructure management. Now, where do we get this blockchain data from in the first place? Antelope operates as a blockchain technology similar to Ethereum, Solana, Cosmos, and others. While our project focuses on the Antelope blockchain, the methods we've developed can be adapted for various other blockchain technologies. Now let's dive into the Firehose/Substreams data pipeline. As you can see on this slide, the pipeline outlines the key stages of the data processing workflow. We start with the extract stage, where we stream block data and create flat files. Following that is the transform stage, which streams transform data and outputs cache files. The load stage uses the Substream Sync SQL tool to efficiently store the data in a way that suits our application's needs. Lastly, the query stage enables us to query according to how it is stored, utilizing the Antelope Token API. This pipeline streams our data management process, ensuring smooth integration and effective utilization of blockchain data for analytics.
Now let's talk about what exactly we've been working on. We aim to quickly insert large amounts of blockchain data into ClickHouse. After exploring various methods like using CSV files and ClickHouse's bulk insert API, we found the most performant method of inserting data to be buffering data locally and sending it as large inserts using the Substream Sync SQL tool. To implement this, we've set up a SQL sync tailored specifically for our use case. Leveraging Kubernetes for orchestration, this sync efficiently processes data from the Antelope blockchain and inserts it directly into ClickHouse. Through our testing, we achieved impressive throughput rates for both inserts and blocks per second. We reached peaks of over 40,000 inserts per second and 4,600 blocks per second in some configurations, demonstrating the scalability and efficiency of our optimized approach. Now, let's dive into a demo of how we're loading blockchain data into ClickHouse using this optimized method. Alright, so this is the GitHub repo for the Substream Sync SQL tool that we are using. So, this is what the setup command looks like. And then the run is about the same thing. So moving on to the deployment. This is how it looks. It's fairly standard. Only special thing is that there's an init container to set it up. So this will run once and then it'll stop and move on to the actual running command. So just like in the GitHub repo, like it's specified, the first command is the setup command, and the first argument is just the DSN, and it's just going to point to our ClickHouse database. This is pointing to our demo database on our server. And then after that, the second argument is the actual manifest. So this is the Antelope Token manifest that specifies what kind of data will be put into the database. Okay, and then for the run, it's same thing. You have DSN, you have the manifest, but we also have some extra options here. I like the flush interval and undo buffer size. The flush interval is something we tested, and we found that 50,000 is really good. 90,000 also works really well. So yeah. All right, so now we're going to run the deployment on our actual server. So first things first, I need to make the repo. create the database. There we go. And our deployment's already pointing towards there, so we can just get started. And here it is. So like mentioned, the first thing it does is the setup. Here we go. Once that's finished, it moves on to actually running the sync. And as we can see here, it is currently running. And if you check the tables, they're all set up. And that is how we are running the sync. Looking ahead, there are plans to further optimize the methods currently in use. Concentration is primarily on EOS, WAX, and Talos chains, with intentions to expand to additional chains in the future. Upon completing the integration of the Antelope Token API, there's an intent to explore other blockchains tech stacks and different APIs they might need. For example, ERC20 tokens, inscriptions, etc. So this is the GitHub repo for Substream Sync SQL. And there's an example you can follow along with here. And you'll find certain parts to be quite similar to our deployment. However, you will need an API key. There's currently a free tier, so you can grab an API key from there. Once you do have that, you can follow along with the example that they have here and be able to run the Substream Sync SQL on a Substream. And that's it for today's video. We hope you found this information useful in how to use substreams to load blockchain data into ClickHouse. Thanks for watching.